Hello, hello, hello. First of all, I missed y'all today. I hope y'all had a great day. I can't wait to hear how your Friday went Monday. But we have a test Monday. So the work don't ever stop. So we got to go over our study guide and make sure we're studying the right things, number one. If you have already made an attempt, that's great. If you have not made an attempt and you're working through it with me, that is also fine too. So let's go over this. So number one, now mind you, this is the exact copy of the test. So as long as you study this, you're gonna do great on the test. First of all, wait. Let me slow down. Let me show y'all. Y'all remember I got a Rubik's Cube, right? So let me show y'all how my Rubik's Cube going. Yeah. Okay, don't look at orange. Don't look at the orange side. Yeah. If it take me as long to do the Rubik's Cube for another video, I'll update y'all in the next video. But let's start. All right, so the two box plots summarize the number of hours spent in the weight room for all the players on the football team for two different high schools. Determine which of the statements A through D below accurately represent the distribution of the data. Write true if the statement accurately represents the box plot. Write false if the statement does not represent the box plot. For all false statements, explain how you know. So that's very important. You can't just put false. Now on the test, it'll be a drop down, and all of this, it'll already be pre-filled in for you, and you just have to pick which one. But let's go through it. Players at school 1 typically spend more time in the weight room than players at school 2. So if we look at school 1, remember typically means our average. Yeah, my computer is dying. Wow. But typically is average. So school 1, school 2. So if I look at school 1 and school 2, my typical would be right here. Now they're saying school 1's typically spent more time in the weight room. Actually, it would be school 2, so that would be false. Ooh, wow. And school 2 spends more time than school 1. Can y'all see that? I hope so. Oh my God. We should count and see how many times my leg breaks. Let me see if y'all can see my writing. Yes, okay. The middle half of the data for school 1 has more variability than the middle half of the data for school 2. If we're talking about variability, and we're talking about variability of a box plot, hold on, writing on my paper. Variability of a box plot, my measure of variability for a box plot is IQR. So we're looking from here to here. Now, in order for me to know how much variability, I need to find my IQR, which is Q3 minus Q1. So my Q3 for school 1 is 10. My Q1 for school 2 is 4. 10 minus 4 equals 6. So my IQR for this one, for school 1, is 6. Now, Q3 for school 2 is 12. Q1 for school 2 is 6. 12 minus 6 equals 6. So my prompt says the middle half of the data for school 1 has more variability. That is also false because they have the same variability. So their IQR is the same. So the median hours spent in the weight room for school 1 is less than the median for school 2. And the interquartile ranges for both are equal. So I know my median for school 1 is less than school 2 because we looked at that up here. And then also my IQRs are the same, which we already found, so this is true. On the test, there'll be a drop down and it'll say the statement was true. Make sure you put that right there. 50% of the players on the football team at school 2 spent 9 hours or more in the weight room. I know that 50% is shown by my median. So that's what I need to pay attention to. So go to school 2. My median is in fact at 9, so this is true. Okay? Bam. Number 1 was not hard, was it? All right, number 2. The histograms show 9 scores on a 10-question trivia game for 2 students. Note that all scores are integers. Determine which of the statements A through E below are accurate. Write true if the statement is true. Write false if the statement is false. For all false statements, explain how do you know. So you're doing the same thing you did for number 1, but it's just a different distribution. So Noah's scores have greater variability than Jada's scores. Variability for histograms you can see by how spread out it is or the standard deviation. So I'm going to look at Noah. Noah starts at 3 and ends at 8. So we're going to say that his variability is 5, right? Just for measurement purposes. Jada starts at 1, ends at 6. 6 minus 1 is 5. So they're spread the same amount. So we cannot say that Noah has a greater variability. So that would be false. And your drop down should say they have the same variability. Now what is annoying is I'm going to have to stop this video at some point because my computer is going to die. All right. The standard deviation of Noah's scores is equal to the standard deviation of Jada's scores. Now, mind you, my measure of variability for histograms is standard deviation. We already know that my spread is 5 for Noah and 5 for Jada. So we can say that they have the same amount of variability or the same standard deviation. The mean of Noah's scores is greater than the mean of Jada's scores. Mean is my measure of center, and especially for a symmetric and bell-shaped histogram like this, remember my mean and median would probably be somewhere around here in the middle. My mean would be right there. My mean would be right there. So who would have the greater mean? Because Noah is pushed over to this side, Noah would have the greater mean, so that would be true. Noah scored better than Jada on every assignment. The key word is every. Can we say that he scored better on every assignment? No, because there are times where Jada is actually scoring better than him. So down here, this is her scores. Our x-axis, these are her scores. This is the frequency, your y-axis. So it's false. I had to cut, guys. Hold on. Had an interruption. But it is false because on some parts, the data overlaps and Jada makes a higher score. So your drop down, this is what your drop down will say. So you don't have to type this or remember it. Remember exactly what it says, but it'll be on the drop down. So the data overlaps. Jada has some higher scores. Okay, so using only Noah's scores, the mean is equal to the median. So forget Jada right now. But even if we were talking about Jada, we would still be talking about the same thing because they do have the same shape. So remember I said your mean and median would be somewhere around here. Because it's symmetric, you would have a equal mean and median. So this will also be true. We're going to pause right here because my computer died, guys. I'm back. Pause for the calls. Okay. So a school toy drive in which students bring in toys to be donated for charity. The number of toys donated by juniors and seniors are summarized in the histograms. Both distributions have a mean of 5 toys. Is the standard deviation of the number of toys donated greater for seniors or juniors? Explain how you know. So this should not be anything where we're putting it in the calculator because we can just look at it. They already told me that my mean is equal, so we're not worried about our measure of center. We're talking about our measure of variability, standard deviation. Standard deviation talks about the spread. So the higher the standard deviation, the higher the variability or spread. The lower the standard deviation, the lower the variability or spread. Okay? So, is the standard deviation greater for seniors or juniors? This is seniors, this is juniors. The standard deviation would be greater for juniors. Fun fact, I always have background music. It's simply better for juniors because of how spread out it is. So for seniors, most of my data is all clumped up right here in the middle. But for juniors, my data is spread out. So I have some data over here, I have some data right here. Okay? The explanation you need to explain, this is a very important part, is the data is more spread out. You will have to type this. There's no drop down for this, so you have to be able to explain yourself. And however you word it, that's okay. But put it in your words, but I need you to somehow be close to the data is more spread out, it has more variability, blah, blah, blah. Okay? And there is number 3. My watch is freezing up, so I can't really tell if y'all can see. I hope so. There it is. Okay. And number 4. The chess club at a school has 50 members. The number of games won in tournament play this season by each member is listed. Create a box plot of the data. So we're going to go in Desmos. We're in Desmos. I had to re-record. So on your test, you should see that link. And when you click that link, you'll see this part. So you're just going to copy and paste this list. And put it in Desmos. So I think that's the old list. I believe that's the old list from the problem before, which maybe I missed. I hope I didn't. I don't know. I really was not paying attention to the video until I needed to do the voice recording. But you're going to put that list in Desmos and you're going to make a box plot. And there's the box plot. Move that over. A little zoom in out action going on. There is your minimum, which is 1. So hold on, let me get my life together, apparently. All right, wait, nope, wrong question. Yep, there we go. So you're gonna see a drag and drop like this. So you're gonna look for the box plot that'll give you a minimum of 1. And then you'll drag it up there whenever you find it. You want a minimum of 1, a Q1 of 4, a median of 7.5, Q3 of 14, and then your maximum is all the way at 28. So when you have a box plot or when you drag and drop a box plot and all those values are in the right place, you know you got that answer correct. I think that's all. Bam. Back to the paper. All right, so now what measure of center is most appropriate to use to describe a typical value for the data in this distribution? So it is asking you, which measure of center should we use? Which measure of center do I use for a box plot? The median. And I also use the median not only because it's a box plot, but because it is skewed right. There's number 3. Hold on, are we recording? Okay, because I can't see. Where's the camera? If y'all wondering why I keep asking, that's what's going on here. But because it's skewed right, we're going to use the median. So which measure is most appropriate for describing variability? If we said median for this one, we have to say IQR. Okay? Remember, median and IQR always go together. Always, always, always. Just like mean and standard deviation go together. So that's number 4. Number 5. Numero 5. The histogram and summary statistics summarize the data for the number of hits in the season by baseball players in 2 leagues. Some summary statistics for the number of hits by players in each league. So League A is the same as this League A. League B is the same as this League B. So they gave you the distribution, and then they gave you your measure of center, measure of variability, and also your 5-number summary. Okay? So use the shape of the distributions to select the appropriate measures of center and variability for the number of hits by players in each of the 2 leagues. So which is my appropriate measure of center? If it is skewed, our appropriate measure of center is median. Simply because it's skewed. Symmetric is the only one where it's appropriate to do mean, symmetric and bell shape. But if it's skewed at all, we use median. So I'll write down here because it's skewed. Okay. If I said median right here, my appropriate measure of variability has to be IQR. Okay. So compare the 2 numbers of hits by players in the 2 leagues using these measures. Explain what each value means in your comparison. So when I told you have to be able to interpret, you have to know what they mean. So you have to know what median is, and you have to know what IQR is. So you'll simply say, and when it says compare, you're just talking about League A versus League B. So League B, or however you want to say it, it doesn't matter. You word it how you want to word it. So League B has the greater median. But if I'm looking at my IQR, how do I get my IQR? I say Q3 minus Q1. So 167 minus 136 is, I'm losing it, 21. 178 minus 145. 333. Yep. League B has a greater median, and League B has a greater variability. So you have to be able to find your IQR, and you have to be able to understand what they mean. But as long as you can compare this, you'll be fine. Okay? So really what this means is simply that League B typically has more hits, and they also have a very higher variability. So they're not as consistent as League A. But, explain that how you want to explain it. I can't really tell you how you want to explain it. Okay? We still on the same one. My bad. Each data set contains one outlier. Can you see? I moved the paper. Hold on. Let me let the little watch catch up. Okay. Each data set contains one outlier. What are the values of the two outliers? So this is more of like a common sense question. So if I'm looking at League A, outliers are something that's different, right? The one thing that's different is this number right down here, and there's only one. So if it's the lowest number, I'm going to look for my minimum value, meaning my outlier for League A is 29. League B outlier, there's only one value that's different from all the rest of them, and that's going to be my maximum value. So League B's outlier is 256. Okay? So that's more of being able to see the difference. I know my one value over here is the only one that's different. My one value right here is the only one that's different, so that would make it my outlier. And it gives you that right here. Okay? If the outliers are removed, which would be more likely to change significantly, the mean or the median? You have to know that mean and standard deviation are affected by outliers. IQR and median don't change. So remember I had y'all repeat, mean changes, median does not? This is it. So which one? The mean. There it is. And there it is then. Is the standard deviation or IQR more likely to change? Because I said mean right here, I must say standard deviation. And explain your reasoning, because we know that standard deviation is affected by outliers. You know what? I always get E versus A mixed up. So today we're going to say E, because who cares? This is math class, not English. It's affected by outliers. Bam. There it is. Look at you making 100 on your test. Are we ready for the next page? Yeah. So below are two data sets that are the same size. The mean and median are given for data set A. Calculate the mean and the median and the mean for data set B. Then compare the median and mean for the two data sets and provide an explanation for your comparison. Okay, so we're going to go to Desmos. Here we go again. So clear out what you had for the last question. And hold on. I am currently working on my Rubik's Cube because in order for me to make a voiceover for Desmos, I gotta watch the whole video, so I'm kind of bored. But I'm gonna type in my list for data set B. You should have 7 numbers in your list. And I'm gonna go down here and I'm gonna say mean of list P, because we keep it P, and the median of list P. Bam. Median is 8. My mean is 11. Now compare the median and mean for data set A and data set B. Then provide an explanation for your comparison. So when I'm looking at my median, we're going to do one step at a time. They have the same median. So data set A and B. They have the same median, but data set B has a higher average. Due to the outlier. And what is my outlier? 33. Because mean is affected by outliers more than median, that 33 is going to change my mean, but it does not change my median. Okay? Because if you look, they really just changed this 12 to a 33. So my median is still going to be, well, you get the gist of it if I was to put my numbers in order. But yeah, my median is not going to change because it's still going to be in the same spot. Okay? A class of students took turns trying to toss 10 bean bags into a basket on the floor 15 feet away. We should try that one day. The number of successful tosses for each student was recorded and displayed in the histogram. Circle the correct statement. So remember when I had put the little 3 histograms or the 3 distributions on the board and I drew the lines? So remember, median is going to be in the middle. If I had to, off the top of my head, I would say my median would be right here. My mean is following the tail of my data. So this would be the tail. Like if I had a fish, this is how we used to draw fish in like elementary school. If I had a fish, my mean is going to follow the tail, not the bulk of my fish, but the tail, because these would technically be outliers. So my mean would push over this way. So which one? My mean is larger than my median. Okay? Real cool stuff, real simple stuff. Nothing too crazy. Numero 8. The numbers on the test is not going to follow the numbers on the what's her name? But same thing. Han found data on the percent of area that is covered by water. Can y'all see? No, hold on. That is covered by water for each of the 50 states in the United States. He made the histograms below to compare the distributions for the states that border an ocean and states that do not border an ocean. So, important information, this is 50 states, this is 50 states, and this is 50 states. But we're just, talking about something different. Which of the following is the best statistical reason for using the median and IQR rather than the mean and standard deviation? Understand that this test is really asking you the same questions over and over and over and over and over again. For skewed data, we use median and IQR. For symmetric data, I hate that my handwriting looks bad, but it's just the angle that I'm trying to write. It's looking very weird over here right now, but that's okay. Mean and standard deviation. This is it. This is all this is asking you. And if you haven't noticed, it's asking you this about this same data the entire test. Mean and standard deviation are more strongly by outliers than the mean and IQR. That sounds nice. This is how you should test. Number 1, read everything. The median and IQR are easier to calculate. I ain't never cared which one was easier to calculate, so that's a no. The 2 groups contain different numbers of states, so the standard deviation is not appropriate. That is not true because we are talking about the 50 states. The 2 distributions have the same shape. I mean, you could say that, but not really. Not necessarily, because this one goes up and then eventually just keeps going down. This one goes up and kind of turns into a uniform somewhere around there. So A would be your answer for the final question on the test. And if you if you follow this video and study this study guide, you will make a certified 100 on the Unit 1 test. Okay?